In this lesson, we'll continue our review of Reading Test 7, Section 1. We are now in the third passage. This is adapted from Patricia Waldron, Why Birds Fly in a V Formation, published in 2014 by the American Association for the Advancement of Science. So remember, 2 out of the 5 passages on the SAT reading will be science. And let's take a look at the very first sentence. Anyone watching the autumn sky knows that migrating birds fly in a V formation, but scientists have long debated why. And right away, that kind of gives you a theory. We already knew it was about, from the title, why they fly in a V formation. And if you've read this, I assume you have, it discussed some theories as to why it referenced a study, as to why, and also how they position themselves behind each other for the V formation. And then in the end, it referenced possible future studies. So let's take a look at the questions. The first one, 22. The main purpose of the passage. This is a general question, right? The whole passage. If you're unsure after reading it the first time, you may want to return. We're just going to do these in order, but you're always looking for a general purpose. And a lot of times they won't use the exact same language that you see. Broad, general language. Is the whole passage about describing how squadrons and planes can save fuel by flying in a V formation? Right? This is not about planes. This is about birds flying in a V formation. This is certainly not what this passage is about, the whole passage. Discuss the effects of downdrafts on birds and airplanes. Again, not on point. Explain research conducted to study why some birds fly in a V formation. That's pretty much stated in that very first sentence. Definitely the answer is C. All right, 23. The author includes the quotation, air gets pretty unpredictable behind a flapping wing to do what? This is what I call a function question. What is the purpose of this sentence, air gets pretty unpredictable? So let's go back to 17 and 18. Excuse me. So I'm going to read, here's 17. I'm going to read a little bit above just for context. Models that treated flapping birds like fixed-wing airplanes estimate that they save energy by drafting off each other. But the currents created by airplanes are far more stable than the oscillating eddies coming off a bird. Air gets pretty unpredictable behind a flapping wing. And so this sentence, this first one, states that it's similar to what airplanes do, but the airplanes are far more stable than these oscillating eddies. Eddies are sort of like these air currents that are moving back and forth. And then we have this statement, it gets pretty unpredictable. So it's really to show that even though it's similar to an airplane, it's not the same, because airplanes are much more stable, but with the birds, it's unpredictable. So let's look at the answer choices. Explain that current created by a bird differs from that of an airplane. Yes, it's unpredictable. The airplane is stable. Another evidence-based question, and the answer is A. All right, let's take a look at 24 and 5, and we're going to always scan down. You see here, evidence-based, so this is a 2-part question. And so we know that the evidence is bound between 3 and 31. What can reasonably be inferred about the reason Usherwood used the northern bald ibises as subject? So why does he use the ibises? So we're looking for some evidence why he selected the ibises. So 3 to 31. So 3 is the beginning of the passage, and you know, ibis is also what I call like a specific word. We don't have any mention of ibis in the beginning. Do we have any mention of ibis here? Let's see. When's the first time we see ibis? All right, so here. So let's start in this paragraph. The study published in Nature took advantage of an existing project to reintroduce endangered northern bald ibises to Europe. So here's really the evidence. It's like, why did they select the ibis? Well, they took advantage of an existing project, and so there was a little bit of synergies there because they didn't have to reinvent the wheel. There was already this project that existed, and so that's what you want to say. This function question is why the ibises were used, and if we look at the choices, the ibises were easily accessible for Usherwood and his team to track, right? Easily accessible because we had this existing study. And the reference to that, let's just go back and see what lines. I believe it was the 20s. Yes, it's 22 to 24. And so this is, again, 2-part question. They perfectly fit together if you do these right. Again, you just have to kind of practice them, but I think they totally fit together. So that was 25. We'll do a few more in this video. Let's do question 26. What is the most likely reason the author includes 30 centimeters in line 30? This is another function question. Again, you have to ask yourself, why does he include this exact measurement of 30 centimeters? So let's go back to line 30. I'm going to read a little bit above for context. So this is about the study with the ibises. Scientists used a microlight plane to show the hand-raised birds their ancestral migration route from Austria to Italy. A flock of 14 juveniles carried data loggers specifically built by Archwood in his lab. So this is introducing this data. The device's GPS determined each bird's flight position within 30 centimeters, and an accelerometer showed the timing of the wing flaps. And so try to think about it, try to predict it. Why is it giving 30 centimeters and also showing the timing? This shows that it's very precise, right? The precision down to 30 centimeters, which is a very small measurement, and also the timing of the flapping, just to show like how much detail it involved. And so that's what you want to look for when we're doing 26. And so to demonstrate the accuracy with which the data loggers collected the data, this looks good to show how precise it was. And again, you see how this is restated. This is just another art of paraphrase question. All right, let's do the last two on this page, 27 and 8. And notice this is another two-part question. So we're going to scan down. We know it's bound between the evidence between 35 and 67. So let's read 27. What does the author imply about pelicans, storks, and geese flying in the V formation? This is kind of like here we had, remember this was sort of a key word, right? About the ibises. So we're looking again for this word, these words, pelicans, storks, geese, and then we can see what the author implies. So 35 to 67. If we start at 35, and you can kind of scan through here, talking about the V formation, there's no mention of those other birds, so it can't be there. And let's go to the beginning of the next one. Here, the findings likely apply to other long-winged birds, such as pelicans, storks, and geese, Usherwood says. And so the findings from that experiment, he's saying it's likely, it's a good chance it could apply to these other birds. And so I don't think this is too difficult here because we found where those were mentioned. So what is he implying? Well, if it would create findings that are similar to the ibises, right? Let's take a look at the answer choices. They communicate with each other in the same way. Is this about communication? They have the same migration route. They create a similar wake. Remember, this is the formation and the flying pattern, or they expend more energy, right? And so the answer here, it's the similar wake, right? The way they fly. And the evidence, that's where we found it. Remember in 47 to 48, let's just take a look at 47 and 48 again. So here's where we found the similar findings. Smaller birds create more complex wakes than would make drafting too difficult. And so all we had to do is really find that key word, and then we see the evidence here.